Our last example, this is how your homework will end with giving you an exponential. Up until this point, we've been given nothing but logs. So now we're starting at exponential. So what is the base of this exponential? This is the base of e. What is the horizontal and or vertical shift? When it is inside the function, that's left or right, and it's opposite. So +3 means to the left 3. That +2 is your vertical shift, and it's predictable. So plus means up. Okay, so now we gotta think about this. What is the domain? Well, I have an exponential. An exponential has a domain of all real numbers. And what is the range? Because this is going up 2, it's taking that horizontal asymptote and it is shifting it up 2 units. So my range is now 2 to infinity because I have a horizontal asymptote at y equals 2. So for these three, let's kind of pull up the graph real quick again. Okay, and here is this, and do remember when I put this into Desmos, you have to put that in parentheses, otherwise only the x will go up. So make sure you include that in parentheses. So that's what I did right there. And here is my graph. And you can see that horizontal asymptote is right there at 2. So my domain going left to right is arrow to arrow, so negative to positive infinity. Horizontal asymptote at 2. So when I go from bottom to top, we start at that horizontal asymptote and that's going to go up forever. So now let's find the inverse, and it's the same steps, but now my inverse should turn into a log. So first step is to replace f of x with y. Step 2 is to interchange your x and y. Step 3 is to solve for y. The first thing I need to do is isolate this exponential, so I'm going to move that 2 over. Okay, I have no way of solving for a variable inside of a log, and I have no way of solving for a variable when it's in the exponent position. So we're going to rewrite this. So I'm going to kind of go the long way, but if you don't need to write this middle step, you don't need to. But we have, when I rewrite from exponential, we're going to write it into an equivalent log. So this is a log with a base e of x minus 2, because we're going base to the other side of the equals, and this will equal y plus 3. Now on the test, if you give me this, I'm going to give you full credit, but we do need to make the connection that a log with a base of e is simply the natural log. So if you don't need this step right here, and you can see that we have a base of e, so you know that's a natural log, you don't have to write that middle step. If you don't write that as a natural log, you're going to get full credit. But again, it's really important kind of going forward that we make that connection. We still haven't solved for y, but now I can get y by itself. We'll subtract that 3 over. Okay, you notice that minus 3 does not go in the log, and I'm not combining that. That does not become a minus 5. One is inside, one is outside. And then last step is to change your y into inverse function notation. So there is my inverse. So what is the base of my inverse? It's a natural log, so that's a base of e. What is the horizontal and or vertical shift? When it is inside, that is left and right, and it's opposite. So minus 2 is to the right 2. And minus 3 on the outside of your function is up or down, and it's predictable. So -3 is down 3. Okay, what is the domain? You have a couple ways to find it. You could type in this into Desmos, use the graph. You could do what we did before, where if you set this to be greater than 0, you can find it, or the domain of my function is the same as the range, or the domain of my inverse is the same as the range of my function. So what was the range of my function? 2 to infinity. And we can find this a couple different ways too. We can look at the domain of my function, because those are going to switch. So the domain of my function is negative to positive infinity. Or any log has a range of all real numbers.